Hello, welcome to a drive-by code session. We're continuing from our last video, which was the introductory video to using Nearley.js to build a parser. And let me give you a recap on where we're at. If you missed that video, I recommend that you stop this video, go watch that one, and then come back. Okay, so this is what we built. We built a subset of a JSON parser, which handles some portion of what a JSON parser needs to handle. So for example, if we give to this parser an array on a JSON encoding of an array with two numbers in it, we run this file, then it is able to parse it. The result of the parse here, the parser, after the parser will output some results. That result is a representation of what it parsed. We have basically hand waved over what that is and how that works, and that's what this episode is going to be about. Okay, so before we get into that though, I want to give you a visual illustration of what actually happens when you take an input, such as this array. How is that represented, or perhaps how is that parsed by the parser? Well, the parser uses a bunch of rules, or these rules, the ones we wrote. Let me move the rules for the number up a little bit higher. The order of the rules mostly don't matter, except for the fact that the very first rule is what Nearly starts with. Okay. Okay, so let's say we have this string input. I'll put double quotes around it so that you know it's a string. Well, how does this get parsed? Well, you might see that, well, there's a number here, the 1, and based on this rule, or I should say a digit perhaps, so the digit 1 gets recognized as a digit. So internally in the parser, that's what happens. A 1 gets kind of internally transformed to a digit symbol. And then further, a digit symbol can be converted to a digit symbol. And then a digit can become a number. And then a number, based on this rule, can get converted to a value. And these sort of conversions, maybe they're not conversions per se, but they're derivations. This is how a very low level thing, a one character, gets sort of increasingly more higher level and abstract in becoming these higher level concepts like numbers and values. Now, how does it get eventually resolved to an array? Well, let's keep going. Let's do this number 2, which will go through the same kind of derivation here. Digit, and then to digits, and then to number, and then to value. Okay, so now we can start with this array parsing. In order to get back to the array, we need to satisfy array items. So let's see how we can get an array items. Well, a value, simply a value is array items. And array items can also be a value and a comma and then some more array items. Well, we already have a value, this guy, and a comma, and this comma here. And then I need another array items, but a value can derive an array items. which is what we need to satisfy this rule here. And we have all things. We have a value, a comma, and an array items. So those three things gives us another array items. And then array items now enclosed in these brackets will finally give us an array. So these three guys gave us an array, and then array gives us a value. And finally, a value gives us the top level input, and we're done. So we kind of work backwards from the lowest level to the highest level. And this is this visual representation is called a parse tree, and we can sort of create some representation of this parse tree, and we can choose whatever representation we want for this parse tree, and for this exercise, we're gonna say the parser is going to generate the JavaScript representation of what that JSON is. So what we're after is that this one here gets us the JavaScript number 1, the 2 gets us a JavaScript number 2, and then this array gets us a JavaScript array. Okay, so that's what we're after. Let's go do that. So we're gonna do that step by step, and we're gonna start with the easy ones first. So to make our lives a little easier, we're gonna start trying to make booleans work. So if we right, again, Waikit did this coding session. I'm replaying it. So oops, I'm not supposed to do that. All right. Okay, so if we run this script right now, it parse is successful. But what we'd like to do now is for this results to give us a meaningful thing that represents this what's being parsed here, which in this case it should be the Boolean JavaScript value true. So what do we do? Well, in Nearly, you can embed JavaScript in this grammar, and the way you embed it is you use this escape sequence, sort of, or escape block that starts out with a let me make the font slightly larger. Okay, it starts out with a open curly bracket, a %sign, and it closes with another %sign and a closing curly bracket. Within it, what you're gonna do is write a function that returns some JavaScript value, and if you're using a version of Node that supports the newer ECMAScript features, then you can use them, such as this arrow function syntax here. So I'm saying to return this true string literal that's been parsed, I'm going to just return the JavaScript value of true. Okay, so now and he put this on a separate line, which is wise, I think, because otherwise, if you do this to longer lines, it'll start getting messy. And he does that for false again. And after you modify the grammar file, you have to regenerate the JavaScript version of the parser, or the grammar, I should say. Ignore that line. Oh, yeah. So now ignore this line here. Don't worry about that. Now the parse success, but there's a true value inside these results. But why is there like 3 levels of nested arrays in here? Well, the first level is expected because parser sometimes may have multiple results. In the case of ambiguous grammars, which is like the same string can be parsed multiple different ways by the parser. Those are in general undesirable, but they can happen, but we're not going to worry about that right now. But now, why are there two more levels of nested arrays in there? Well, it's because that's how many levels of derivations there were to parse this Boolean value. Okay, so let me draw that out. So if you have the string true, then then that derives the symbol Boolean, and then a Boolean here derives the symbol value. And finally, the value derives the input symbol. So, and we said this guy, when this true matches based on this Boolean rule, we're saying in order to represent a Boolean here, because this is the rule that defines what a Boolean is, we're saying if you see the literal true, then I want to represent this Boolean with the JavaScript value of true. So in a sense, we're like attaching this value to the Boolean. Okay. Now, when we activate this rule here to derive a value from a Boolean, the way Nearly works is it'll take the symbols that are matched on the right hand side, in this case there's only one of them, and put it in an array, and then this guy gets promoted to be represented by the value unless you perform a transformation. So basically the value that got promoted to the JavaScript value that got promoted to the value symbol is true inside an array, and then this happens again with this rule here. This outer array is wrapped around the thing that got passed to it to represent value, and therefore we got two array wrappers around this true value, which looks a little bit weird. And the way that you can sort of unbox it, which I think would make sense to unbox these arrays in this situation, the way you do it is like this. You take the data that is represented, which again, it's gonna look like an array with just one thing in it, because there's only one symbol on the right hand side of this rule here. And you just unbox it. Yeah, because the data is an array, you're just gonna get the 0th element out of it. And then we'll do the same thing for this rule as well. We'll unbox the first symbol, the value within the first symbol of the right hand side, which is the value. And then we'll say that is the thing that represents the input now. So now if we regenerate the parser and run it, then we just get one true. Again, this outermost array is expected because the result of the parser, that can potentially be multiple parses coming from the parser. So this is cool. Now, because this pattern is so common, and in a lot of cases where you have just one symbol on the right hand side of the rule, you probably want to do it. Because this is so common, Nearly gives you a convenience function called ID that does exactly that. So you can write this in a lot shorter way, and it does the same thing, as you can see. So we're actually gonna do this for most of the rules, almost all of the rules, where on the right hand side there's only one symbol. So he finds all the rules, although there are some special cases where that's not what we want, and I'll show you that later. So these cases, see where the right hand side there's only one symbol, we're gonna say use the ID function, which just unpacks that array. But for the ones where there are multiple symbols on the right hand side, we're not gonna do that. Okay, so for the null as well, we'll just say for the this one we're not gonna, this is a literal, so we handle it like the Boolean ones, like the true and false ones, and you're not even caring what the data is in this case. If you did receive the data here, then the data would be this string in an array. Okay. Okay, so now we're gonna handle the array. So for the array, to represent an array, we want to use an array, a JavaScript array to represent an array. That seems logical. So we're saying if we match this empty array, we're gonna return a JavaScript empty array. And then if we get some array items, we're gonna return the representation that was returned by array items. And to help you visualize this, so this is an array, or data is an array that contains three things. One is the first symbol, which is the open bracket. The second one is array items, or I guess I should have said the 0th one is the open bracket. Then the first one is array items, and this close bracket is the second one. So the data that's gonna come is gonna come from the array items. So therefore, that's the one indexed at 1. But we haven't really done anything with the data associated with array item. Oh, we have done this one, but this is wrong actually. We need to fix it. So let's see what we're gonna do here. So because we're saying array items, we're gonna make it return an array. There's actually, he made an error here. He forgot to close this bracket over here. So yeah, there needs to be a closing bracket here. He's gonna fix that later. So if you match one value, or there's one item, one value within the array, we're gonna return an array that wraps around it. So this is very close to what ID does, but not exactly, because we want to wrap an extra array around the inside. And actually, now that I'm thinking about it, maybe this is exactly what it would have done if we leave this out. But that's cool. And then if there's one value and then a comma and then another array items, which could have come from the previous match of array items, which we know is an array of items, then we're gonna make a new array and then put the 0th one here. So this guy is 0, this is 1, this is 2. So we know 2, data index 2, this is going to be an array. So we use the spread operators to basically copy the contents of this array. We know this guy is an array. So we take this array and copy it into this new array that we're making. So that's the plan. Let's see if it works. No, because there's a syntax error here, as I mentioned. So I think he has to fix it. Yeah, there. He fixed it and regenerate the parser again. And now we get an array of 1, 2, and 3, but they're strings now. So, but we're expecting numbers, aren't we? So let's see how we can convert them to numbers. Oh, he wants to test it for true, false, and null first because those are already working and looks like they are. So this is great. True, false, and null inside of an array. Next, perhaps he wants to tackle numbers now. Yes. So we have an array that has a 12 and a 3 in it. Let's see here. So to convert a string, because when string information is coming from the parser and you want to convert it to a number in JavaScript, a good way is just using this number function, and the data is gonna come in as an array of stuff here. I think array of strings, although it depends on how we represent each thing, right? Here, this ID, let's see, this ID will cause digit to be represented by a string. This one as well. So I think here he's saying, is this gonna join all of the data together, where the first one is a string, the second one I think might be an array though. Oh, we got 12 now. On second thought, the data conversion should probably be done at the number level, because when you're concatenating digits, it's more cumbersome to like convert to a number and then convert back into a string to concatenate them. So in the digits phase, let's just leave them in strings so each process concatenates them. So I'll make it more clear what I mean here. So let's say you have a string 1 and 2, and this guy gets matched as a digit, and so does this guy, and then a digit gets promoted to digits here based on this rule here. And then both of them get combined based on this rule. A digit plus a digit is also a digit. Digits. So at this stage, you have a 1, a string 1, a string 2, and here at this stage you still have string 2, and at this step of the combination you should get combined string 1 and 2 to the string 1, 2 to represent digits. And then the plan is in the next step where a digit gets promoted to a number, that's the point where we actually parse this string of numbers into a JavaScript number. So we remove the quotes here using this conversion function number. So that's the plan. I think that makes more sense. Let's go for that. And then when it's a decimal number, we do the same thing, except we add the decimal point in before the number conversion. Okay, and now we have an array of numbers. The numbers 12 and 3, and that works. Okay. And let's see, it works for decimal numbers as well. Awesome. Now let's do strings. Strings might be a little hard, and currently it looks like this, which doesn't look like a string. It looks like quote, an array inside it, and then another quote. So how do we do strings? Waikit, tell us. Okay, so a string has been matched using this scheme here, based on these 3 rules currently. The first rule is a string is a double quote followed by some characters followed by another double quote, and then what's a character, or what's a characters, plural. A character can either just be one character, or it could be a character followed by more characters. So that's the recursion trick. And then what's a character? A character is any character that is not a double quote. Obviously, there's problems with that, such as this language cannot support having double quotes in strings, but we'll fix that in a separate episode. So for now, we just cannot have double quotes inside of a string, and that's fine. And this ID is saying the thing that the value we're gonna use to represent this character is just whatever the string that has the character in it. And then here, let's figure out how we're gonna represent characters, obviously strings. So I'm gonna see string concatenation here. Yeah, this is wrong. This should be data at 1. So he's gonna have to fix this. So because this, you can look at this as an array, and then this is index 0, this is 1. So he wants to concat the first character to the next characters. First character is index 0, but the next characters, it should have been index 1. So I think he messed up there. Yeah, he gets this age undefined. It should have been hello, but you get age undefined because index 2 of data is undefined. So he fixes that. Cool. Has to regenerate the parser, and now we get the string hello. Okay, so now the parser should support all of these values now. And it does. Very cool. Okay, so that's where I want to stop. In future episode, we'll keep going, and we'll talk about how to do white spaces, and also how to parse strings correctly with escape sequences to allow the inclusion of double quotes, for example. Yeah, see you next time.